Next application, so in Newton's laws of motion. So pulleys I'm explaining now. To calculate the tension and the acceleration of the two blocks. This one. Suppose this is one rigid support and one pulley is fixed here. One rope passing over the pulley. Rope passing over the pulley. Two blocks connecting here. This is the first block of mass M1. And this is another block of mass M2. So gravitation weight acting on the first block M1G downward direction, and on the second block also gravitation weight acting downward direction M2C. But the tension acting opposite to the gravitational force. So here tension acting like this direction, and here tension acting this direction. So suppose here condition, if mass of the first block greater than, if M1 greater than M2, the first block when the system releasing, when the first block is moving downward direction, at the same time second block moving upward direction. Because due to the mass variations, it is moving downward direction, this is moving upward direction. Now we have to find here how much tension developing in the string and with what acceleration the two blocks system moving. One is moving downward and the second one moving upward direction. So for this one, the resultant force I am calculating now on first and second blocks. But on the first block, two forces acting. Out of these two, tension T and M1G. M1G I am taking positive and T is negative because M1 block moving downward direction along the system moving. System means here M1 block, M1 moving. That direction force I am taking positive. So therefore that F net force acting on first block is equal to M1G minus tension T. But F net nothing but according to Newton's second law, mass into acceleration. Then this is M1A is equal to M1G minus T. This is equation 1. Similarly, the net force acting on the second block, so M2A is equal to, now T positive because second block moving upward direction. So this is T minus M2G. This is equation 2. Now I am adding these two equations, first and second one. Adding these two, 1 plus 2, M1A plus M2A plus M2A is equal to, so minus T plus T cancel, then M1G minus M2G. So now left side we are taking common A common, M1 plus M2 is equal to, so take right side G common, then M1 minus M2 into G. So finally acceleration of system A is equal to M1 minus M2 divided by M1 plus M2 into G. G is the acceleration due to gravity. This is the acceleration of the two blocks, first block and second block. If substituting this A value in equation 1 or in equation 2, we'll get tension. Suppose I'm substituting in equation 1. From equation 1, so tension T is equal to M1G minus M1 into A, which is equal to M1G minus M1 into, already we calculated A value. So that value I'm substituting here, which is M1 minus M2 divided by M1 plus M2 into acceleration due to gravity G. But which one we can take common here? So M1G we can take. So if you are taking M1G, then this is 1 minus M1 plus M2. So after taking LCM here, M1G into M1 plus M2 minus M1 minus of minus plus M2 divided by M1 plus M2. So in this equation, this plus M1 minus M1 cancel. So after cancel, tension T is equal to M2 plus M2 to M2. Then 2 M1 M2 divided by M1 plus M2 into acceleration due to gravity G. This is the tension T. And next, one more application. So if I'm taking one block on horizontal table and one is connecting by using a pulley. So in this also same, we have to find tension T and acceleration A of the two blocks. See this diagram here like this. So here one pulley connecting. So here pulley connecting, and one block is placed on this horizontal table. Like this, two are connecting here. So this block mass M1 and this block mass M2. So gravitational weight acting on this block M1G and tension acting upward direction. And here, which block is placed on the horizontal table? So this normal force N exactly balancing by so M2G. Then tension acting along this direction. So same condition I'm using like before. If mass of the first block greater than mass of second block, now first block moving downward direction in acceleration A, second block moving along this direction. So after applying similar concept, resultant force acting on first block and second block, after that, you are adding here, you will get acceleration and tension. So directly I am writing here two equations. Resultant force acting on the first block, M1A is equal to, so M1G minus tension T. Minus tension T, this is equation 1. And on the second block, M2A is equal to only tension T acting, because that normal force N and M2G both are cancelled to each other. This is second one. If adding these two equations, so this minus T and plus T both are cancelled to each other. After cancel and taking left side A common, then M1 plus M2 into A acceleration is equal to M1G. Therefore, acceleration A is equal to M1 divided by, it is M1 plus M2 into G. G is the, putting this acceleration A value in equation 2, easily will get tension. Therefore, tension T is equal to M2A. Then after substituting A value, M1 M2 by M1 plus M2 into G. You know, G is the acceleration. Next, one more same application based on this one, Newton's laws. Third one. Now here, two blocks are contact to each other. Suppose this is a horizontal surface, but frictional force negligible here. One block is placed on the horizontal surface here, and the second block placed like this. Mass of first one M1 and mass of second one M2. So some external force F acting on the first block of mass M. The total system of two blocks moving with an acceleration A. Now here, two values we have to find. First one, what is the acceleration of the two blocks of system, and the contact force. How much contact force developing between the two masses of block M1 and M2. So we know here two blocks are contact each other. So contact force developing between the two objects. We have to find that contact force also. So first here same concept I'm applying. So resultant force or net force acting on block M1 and M2. After adding those two equations, we'll get acceleration. So first resultant force on M1. M1A is equal to F minus small f. The small f is the contact force which is exerted by second block M2 on M1. That's why I put here negative sign. Because according to Newton's third law, action and reaction. The force exerted by M1 on M2, and at the same time the force exerted by M2 on M1. So that force opposing the motion of M1. So I subtracted from the total force. So similarly, on second one, M2A is equal to only one force, contact force only acting. Same if adding these two equations, contact force F and F cancel here. So after cancel and take common A value, M1 plus M2 into acceleration A is equal to force F. Therefore, A is equal to F divided by M1 plus M2. This is the acceleration of the system. And similarly, contact force F is equal to from second equation I am taking. So it says M2 into A value F divided by M1 plus M2. This is the contact force. Next, one more application I am discussing here. So suppose this is the rigid support and one pendulum bob connecting like this. If the pendulum bob is pulling one side until it makes an angle theta with initial position, how much horizontal force applying here? F is applying, and the tension developing in this one is T. So if this alternate angle theta, so this T I am resolving here. This force is T cos theta. This is a T cos theta, and this is a weight of the metal bar, and along this direction T sin theta acting. This is a T sin theta. Now at equilibrium position of the metal bar, so we can equate upward force is equal to downward force and horizontal force in the right side force is equal to left direction force. It means T sin theta is equal to force F. This is equation 1. And upward direction force P cos theta is equal to downward force mg. This is the equation 2. If I take in the ratio of these two, T divided by cos theta is equal to F divided by mg. But we know sin by cos is tan theta. Tan theta is equal to F by mg. If cross multiplying here, that force F is equal to mg acting on the metal bar. And to calculate in tension developing in the thread here, from equation 1 and 2 will get, so squaring and adding equation 1 and 2, squaring and adding these two equations. Left side first I am taking first equation, T square sin square theta, second equation, T square cos square theta is equal to first one F square plus second one mg square. Right, so here T square value taking common, then square theta